Howdy students, this is going to be Unit 16 Notes, Part 1, B, the second section here, and in this video we're going to look at oxidation numbers. In the first video we looked at oxidation versus reduction, the difference between those two, and so oxidation numbers are an additional step that we can use to identify which chemical species are reduced and which ones are oxidized. So an easy way to determine what element is oxidized and which element is reduced is to look at its oxidation numbers. These are going to give the charge on each element in a chemical reaction. So if lead loses 4 electrons, it takes on a charge of blank. So lead is Pb. If it loses 4 negative electrons, it is going to become plus 4. Does this mean that it's oxidized or reduced? Well, in our last video, if we lose electrons, that is an oxidative process. Okay, so we have some rules for assigning these oxidation numbers. Remember, when there is one element left, don't look at the rules anymore. Okay, so the sum of the oxidation numbers is going to equal the overall charge of a compound. Free elements that are by themselves, like sodium, or we might see O2, any of the diatomics, those are going to have oxidation numbers of 0. Alkali metals, which are group 1A elements, like lithium, sodium, potassium, rubidium, and cesium, those all have plus 1. Hydrogen is also a plus 1, and again, that's found in group 1A. Group 2, along with cadmium and zinc, all have 2+ oxidation numbers. Oxygen is always a -2. And then the halogens, group 7A, fluorine, chlorine, bromine, and iodine, are all -1. Transition metals, and I'm going to add any other elements, are going to be the ones that you actually have to solve for. So we're going to have to do a little bit of solving in order to label all of the oxidation numbers. So keep these in your notes. You're going to refer to them anytime you need to assign oxidation numbers. Okay, so let's give the oxidation states or the oxidation numbers of each element in the following molecules. HCl. Well, hydrogen is +1 and chlorine's -1 according to our rules. So those are nice. We know the oxidation numbers for both elements. And those two added together are going to equal the overall charge, which we did not have an overall charge. If we did, it would have shown up somewhere in there. P2O5. From our rules, we know that oxygen is a -2. However, we don't quite know what phosphorus is. So we have to actually set up an equation to solve for phosphorus. So I don't know what the charge is, the oxidation number on phosphorus. So that's my X. That's what I'm trying to figure out. There are 2, P2. So we have 2 times X plus the -2 oxidation number for oxygen, and we have 5 of them, right? It's O5. The overall charge is 0 because there's nothing above this molecule indicating that it's an ion. And when I solve, I'll do it over here. 2x minus 10 equals 0. 2x equals 10. X equals a positive 5. So the oxidation number for phosphorus is a +5, which doesn't quite fit our old rules. A long time ago, we would have said that phosphorus had a 3- charge, but not in this case. H2O, hydrogen is +1, oxygen's 2-, so we actually don't have to solve for this at all. NH4+, H is 1 plus. We do not know nitrogen, so we're going to set up an equation. This is my X, so there's nitrogen. I have H4, so I have 4 times plus 1. Now, my overall charge is a plus 1. When I solve for nitrogen, I get a negative 3. O2, oxygen's always 2 minus, except this is free element in its standard state. So you may want to list out the diatomics again into O2, F2, Cl2, Br2, and I2, and H2, of course. Free elements are always 0. MnO2, oxygen's 2 minus. Manganese we do not know. We will have to solve, which is our X value. O2 would be 2 times that negative 2. There's no overall charge. When we solve, we get a positive 4 for manganese. And Na2SO4. So on this one, group 1 for sodium, and then oxygen's 2 minus. We do not know sulfur. That's what we're solving for. We will have to set up an equation. So here is sulfur, S1. Here is O4, 4 times negative 2. And then here's sodium, 2 times plus 1. Kind of went out of order here. And we can go ahead and solve X minus 8 plus 2 equals 0. That would be X minus 6 equals 0. So sulfur should be a positive 6 when we solve here. Aluminum phosphate, AlPO4. Aluminum is plus 3. Sometimes we will need to provide you with a number in order to solve. Oxygen's 2 minus. We're going to have to solve for phosphorus here. Here's our aluminum. Phosphorus, here's O4. Overall charge, I do not see one. Phosphorus is plus 5 in this case. Calcium hydroxide, I know group 2, I know hydrogen, and I know oxygen also. So in this case, I don't have to solve. But you can prove with your equation, just in case you need to. Titanium oxide, last one here. Oxygen's 2 minus. And in this case, titanium will have to be a 4 plus in order to reach the overall charge of 0.